get my clamps together. I'm Garrett with IDC Woodcraft, and in this video is going to be my very first carve on the Altmill CNC router. It's been quite a long time to get this thing up and running with business and all, but I've got it. The only things I have left to do is surface the spoil board and tram the thing, but I just can't wait. I gotta see how this thing runs. A couple little test things I've done, and it looks like this thing flies. So who do we got on board? Do we have anybody on board yet? Okay, all right, it'll show up.
Oh, one person.
All right. Yeah, that's what I need to say who's on, and then they pop on. Yeah, I'm Garrett with IDC Woodcraft. I have to say it again. And we are going to do our first carve on the Altmill CNC router, 4x4 machine. And I've done some practice runs with this thing, just moving it around. I did a couple of like just play cuts, just little things. But this is my first sign project. So what I'm going to do is a V-carve of a very special sign, and then we're going to cut it out. So we're going to do this with this piece of oak. And I am going to do it with another router bit that I am testing. Bring that camera over here. By the way, Julianne is actually driving the camera today, not Adam, because Adam is editing a video about the T-tracks. I'm shooting it. If you bring the camera down here to show them the T-tracks here, just so people understand what they are and if they're good or not to use. So anyway, that's so Adam's busy on that because we want to release that tomorrow.
And Charlie asked if it's more rigid than the Onefinity.
Well, Charlie, I don't have my hands on Onefinity, but I've had my hands on Onefinity like at shows and stuff. And I would say that they are very comparable in their rigidity. So it's a really good question. Here's one of the things that really kind of impressed me on this when I got it. In the gantry, so bring the camera over here. This is an extruded aluminum piece for the gantry.
Caught here. There we go.
Okay. It's extruded aluminum, and that's about 6 inches tall. And if you come up to the top, it's about 3.5 inches wide. And when you look at the end of it, the extrusion material thickness is like that. And then here, they've got a 5/8 thick piece of steel for the gantry mounting brackets. So that is quite stocky, and just from an engineering standpoint, when they're using a box gantry, so box gantries are strong. The Onefinity has the 2 bars, but they're pretty thick, and they got the same here on the side. It's a little bit thinner, but it's all supported by the bracketry that's underneath the machine. And so, yeah, so it's ball screw, you can see that. It has linear bearings as opposed to a bushing. And the difference with a bearing versus a bushing, which is, I believe, what the Onefinity has, is a bushing slides along around tube. And it's just a really precise fit, whereas a bearing uses ball bearings. Right, so, all right.
Hi, Joe.
Hey, old Joe, what's going on there, bro?
He said the entire IDC team could stand on this machine.
You know what? Let's just.
Oh, here we go.
So when I do my, I have no qualms about standing on this thing, but when I do this is rock solid. When I do the review video on this thing, I'm going to ride it. I'm going to ride that gantry while it's carving. So, okay, so let me tell you what I've got for I'm going to do the setup. I just figured I'd just start. We're going to be at this for about 45 minutes. We may be, if the video gets a little jerky, it's only because the camera's getting hot and we just have to deal with it. So, all right, here's the way I'm set up. I've got a piece of oak here. It's actually 3 pieces that I've glued together. And I've already surfaced this side. Now, mind you, I did not surface the spoil board yet because I just want to get this thing cutting. Just to gotta taste it, you know? And so I'm gonna hold it down using 2 methods. I'm using double-sided tape This is from X-Fasten. Let's see if we got any over here. Well, it's this stuff right here, okay? And X-Fasten woodworking tape. So it's a very thin double-sided tape, and the stuff is pretty strong. Like when you peel it off, it's like stuck to your hands and all that stuff. It's like, can't get it off. Anyway, so I'm gonna give you some tips as we move along as I set this up. Number one, when you use double-sided tape, first of all, I'm using it because this is gonna be a complete cutout, no tabs. I'm also gonna use the clamps for on the T-track to hold the corners down of the waist piece. So when you put the double-sided tape down, I always put it down on a spoil board first. It's really, for me, in this case, it's just there to keep that middle sign in place when the final cutout is done. But the reason I put it on spoil board first and then I'll press it down is because we want to get good adhesion to the spoil board, and then we can clamp down or press down from the top to get the adhesion onto the back of the board here. But this is not planed. I mean, I'm too impatient at this point. So we're just going to rock and roll. So I'm going to peel away.
While you're peeling, Robert had a question.
Fire away, Robert.
Can you convert a belt-driven CNC like Carve into a ball screw?
You know what? With enough mechanical sense and ability, you can. Personally, my feeling is that the effort to do that is going to far outweigh just replacing the machine. Because first of all, let's just get this thing set down and generally in line. There we go. And is that where I like it? I guess I'm going to have to like it because it already stuck to it. All right. With the balls, so you said belt drive, right? Okay. So belt drives, when you run a belt drive, the belt runs across the rails, and then it does one of these things through the motor gearing, all right? And the motors are on the side of the gantry when it's moving it in the Y direction. You have to convert those motors to the back of the machine or the front of the machine, because the motor is going to be directly tied into the ball screws, and then you're going to have to get into your control software and change your steppers, the stepper resolution to accommodate the ball screw relative to the roller motion that you would have. So it'd be a pretty complex setup. I mean, if you really want to dive in and do some crazy stuff, I mean, go for it, brother. But at the end of the day, I'm all about cutting and not building stuff. I love to teach, right? So that's one of those things. When I get technical questions, I usually divert them to other people. If you want to take that on, you may want to check. There's a Facebook group that I had a friend start because he was a technical genius. It's been a long time since I've talked to him. It's called CNC Troubleshooters. But when push comes to shove, if you want to just cut, then maybe sell the machine and go find, get one that's ball screw. I am really about the screw drives. So the way the T-track works, now I'm going to get different clamps. You can see these are kind of thin and not that strong. So I am going to put in the description of this video later T-track, and I'm going to put a couple recommended clamps. But anyway, the way these things work, obviously you can see, Julianne, if you just show this right here. And by the way, whoever's on, just say hi to Julianne.
Hi, everybody.
Yeah. Well, it's pretty obvious. You got the foot here, and then the threaded the hand knob, and then it's going to push down on the corner of the piece. The one thing we want to make sure, you can see it's thin. It's not the strongest steel, so.
Oh.
I think I broke the plastic. That's printed, 3D printed. So that's why I'm going to replace these. As a matter of fact, IDC Woodcraft is going to be carrying. I got to go through some clamps samples, and we are going to start carrying T-track and clamps. All right, let's get this last one set up. Okay, so any questions?
None yet.
No? How many people got on board?
We have 34 people.
All right,
Yep.
all right. So yeah, basically what this is this is my very first run with the Altmill with a project I designed. Little special thing for me. If you've watched me long enough, you know I set goals for myself. And so this is something that I'm setting a goal for myself. And so you'll get to see it when we're done. All right, so this is a piece of oak. I have Oramask on top, so after I carve it, then I'll be able to spray paint. I'll clear coat the carved letters, and then I'll spray paint them black, and then I'll peel the Oramask away. Maybe I'll stain things up or something like that. So let's show you, let's come into the bit here. So this is a bit that I'm testing. This is, the intention with this is a long life V-bit. But we'll see. I just want to see how it cuts. So hopefully this thing doesn't mess up my project here. All right, so I'm not going to use the probe on this. I'm just simply going to zero out using the touch method. But I'm going to, so this is the rapid move from G-Sender when you're moving the thing around. And here's how fast it goes. All right, but I want to give you an idea how fast it goes. First thing I'm going to do is send it home because I haven't sent the machine home. So this is the homing speed. I got to wait for everything to get home. Okay, and then I'm going to zero everything out right there because this is going to show you how fast this machine travels at its maximum travel. So what I'm going to do in G-Sender is I am going to, let's go across on X, I'm going to type in a command that's going to be G28. So I made my XY0 position in the back corner. I'm going to type into, I'm going to put a mount for a computer over here too. But I'm going to type into the console a command called G28 X0Y0. And when I hit go, that thing's going to go at its fastest rate back to the home position. So watch the machine. Nope, I got an error. So what did I get? Oh, I know what I did. G28, G20, X0, Y0. Okay, so that's the fastest that they have set the Altmill default speed, so that was pretty fast. I think that's set at 600 inches per minute. So we're going to bring this in and we are going to zero out. So first of all, if the video is getting a little jerky, it's warm in the shop. As you know, we're in the middle of a heat wave, and that starts to affect the cell phone. I need to get a piece of paper. Like I said, I'm just going to do the touch method. I'll play with the probe later. I just want to play with this thing, get it going. And so this is live, total live, first time with the Altmill. See how this puppy runs. And get things into position. And then we're going to slow that down. All right, this is a pain in the butt when I got to keep turning back and forth looking at the computer.
Will you be using a vacuum table with the Altmill later?
Later on.
All right.
Later on. So let's get this puppy down there. Okay. Ooh, that was good. I mean, that was so close, it was scary. Oh, there's one tap, and that was it. Okay, we're going to zero out here. Okay, and we're going to bring it up. So this bit, I'm setting at 20,000 RPM, so it's pretty fast. And starting out at 120 inches per minute. Now I got to load up this program, the first one. So this is called 4%. And there we go.
Did you do keep out zones in the design for this?
I did not because I zeroed off the middle, and I specifically intentionally zeroed off the middle because of that, because I didn't want to, I wasn't going to work with the keep out zones. But I did pay attention to the cutout size and all that, so that we are away from there. the clamps. But of course, I got an emergency stop right here on the side that my hand is going to be on. And I guess we're about ready to rock and roll. So I'm scared.
Just do it.
I'm scared.
Push the
All right.
button.
All right, hit the button. So we're going to hit start and hand on the stop. Always, always, when you hit a start, get your hand on the stop button. If you've been doing this for a while, you know exactly what I'm talking about. And so here we go. We're going to fire up to 20,000 RPMs. Now it's going to delay for a minute because I got a delay in the program for this to wind up. And then there's another default delay. So here we go. I might have to give Julianne. Oh no, that's not so bad. All right, so in general, these are pretty light cuts. Let me get the microphone a little closer to me. They're pretty light cuts. When we get in the middle, it'll be a little heavier. Oh, that's a clean cut. Put your finger on there, Julianne. All right. Any questions in the meantime?
Not yet. Everybody just wants to see it carved.
All right. So I'm going to speed it up. We're at 120 inches per minute right now. And I'm going to bring it up to 150%. There we go. So it is now running at 180 inches per minute. Still nice and clean. Let's amp it up some more. Oh my God. This is so fast. Okay, 200%. Wow. So it's starting to get a little bit rough on the cut. But on the top, it's still super clean. So we're going to back it down to 100. All right, we're at 170%. Wow, this is like really fast. I mean, you've seen the long mill run. Yeah.
They're asking how much does this machine cost and are there smaller sizes?
So, okay, so that's a really good question. When I talk to, you can keep watching that, let them watch that, I'll just talk to them. So, it does not come in a smaller size yet, but I was talking to them, I said, you guys got to come out with a 2 foot deep machine. And they actually asked me to ask you guys if that's something that you would want. A machine that's smaller. So put in the comments what sizes you might want them to consider. What I can see them doing is there's two ways they can do this. They can either make the gantry narrower or the depth of the machine shorter. So what would you want? Because they are curious, and I know that they need to do it because this thing runs. Okay, so I have a link that I will throw in the description of this video afterwards. If you want to go look at this, it's an affiliate link, so if you decide to look at it, please use that link. Holy cow. Okay, watch this little thing that's gonna carve next. It's gonna carve here next after it finishes that out in the line. This is a little special symbol of mine. Boy, you can't even hear that thing cut.
They asked what size the V-bit was.
Okay, so this is 90-degree V-bit. It's one that I am testing. And
Oh, looky there.
yeah, it's got, well, that buildup right there is from the Aura mask.
Comes off pretty easy.
Yeah, yeah. A little bit of, there's adhesive behind the Aura mask. Okay, so this 90-degree, and that is 3/8. And so what I need to do now is the cutout, and that's going to be a little noisier. That's just, when you're doing cutouts, that's just the way it is. I don't need to do that. I just need to, I love how fast this thing goes. I set myself up with a 1/4" down cutter. So I got to get that bit. I think I had it over here. And for this, I am going to cordially put a set of earmuffs on Julianne's head.
Oh, yay. I don't
Because-
get to go deaf today.
Yeah. Yeah, so we're going to change out. Again, like I said, I haven't used the touch probe yet. I just want to run this thing. So for anybody who's jumped on, this is the Altmill CNC router. It's a new CNC router put out by CNC Labs, the same company that makes the long mill. And, oh, someone asked how much is this? This one is like $29.95, you know. And then if you want the spindle attachment, it's like another $500. And so this is the bit we just ran. So it's solid carbide. Right, and that actually cut quite well and very well balanced, so I like that. All right, we're gonna put that back in the case. Again, it's a test.
What's the feed rate of the 90-degree V?
That one we just ran at 160%. So I initially set it up to 120 inches per minute. And so you times 160, so 60% of 120, 60, 70, I think I ran that about 210 inches per minute. And cut clean. There's a little bit of roughness in there. Just a little bit. The very top is super clean. So if I want to get a cleaner finish, I'd probably back it down to 150 for that guy. Okay, so we've got the down cutter on here. This one's going to make a little more noise. With spindles, first of all, if you have, have the option of a spindle for a CNC router, as opposed to getting a trim router on the machine, like a Makita, then the spindle is much quieter when it cuts, so there's not much difference in the noise, but I mean, you don't have the compounded noise of the trim router. The spindle cut much cleaner because the bearings are much more precise than on the trim routers. Okay, so when we are working with a bit like this, it's going to make more noise.
Let's see. We also have a question. What's really the difference between this 90-degree and the 90-degree that you currently have?
Okay, so it's a good question. So first of all, there's the SV90, which is the 1/4" 90-degree V-bit. Let me pull one out of my drawer over here. What's that?
Is that a Liberty just passed through the background?
Oh, okay. So this is an SV90, and this is a blade style V-bit. In other words, when they grind it, that cutting edge is more like a knife as opposed to a flat edge. And so this one has a flat edge, the one we just did. And so then there's the BV series, which are the larger ones. And those are brazed tip bits. And that means they have a carbide piece brazed onto a different metal, 4140 steel. And they do that because carbide's expensive. So it's just a very common way of doing that. So yeah, that bit, that's solid carbide, the one I just did. Okay, any other questions before we fire this up?
Mark asked what wood we're cutting, but somebody already answered him. Oak.
Yeah,
So.
it's just oak. It's just a store-bought oak. Again, this is, I just surfaced the one side. I surfaced it on the long mill. I didn't surface the back side. So the difference in thickness from one end to the other is 0.01. So I'm probably going to cut just a tad into the spoil board at some point. But I haven't surfaced the spoil board. I just want to run the machine. And so that's what this is. It's just an anxious, let's get her done and see how she goes and get this little sign that I made for myself taken care of. And it's playing a little bit with the speed of the machine too. All right, so I got this. I'm going to throw these on Julianne's ears.
Oh boy.
And oops, got to stretch that out a little
I got a
bit.
big head, so.
She got a big head. All right, are we okay?
I guess so.
All right, it's temporary. And I want mine too. So we'll get the other set. All right. Say hello to Julianne. Now we do the cutout. This is where the real rubber meets the road, where more forces are going to be put on the material. I am cutting, let me just give you a rundown of what exactly this depth of cut is. My settings on this, I am cutting all the way through, 3/4 of an inch. We're going to make 2 passes, and I am turning at 20,000 RPMs, 120 inches per minute, and I'm doing it on a spiral cut. Oh, I got to make sure that, oh crap, I got to fix that. So 120. So basically what I'm doing, a spiral into it. The spiral is the plunge rate, and so I need to set that up to the standard feed rate. So to do that, got to rewrite that tool path real quick. And then I'm going to just regenerate that. I guess we should take a look and see what it does. Reset, preview all tool paths. Okay, happy with that. Let's see what this baby does when we do this cutout. So this is, yeah, first cutout. Get the right one, save that tool path. We're just going to call this 4P cutout. Okay. How many people on board?
53.
All right. Hey, I hope everybody enjoyed that live last night with Izzy Swan. So we had Izzy Swan on our regular Wednesday night live as a special guest, and I was so excited. And Izzy is an incredible person, and he's got so much knowledge up there. What did you think, Julianne?
I'm like really having to focus with.
Oh, okay. Never mind. Okay.
It was great.
Yeah, she's colder. Now, it was really a lot of fun. I was really grateful that he said yes. If you don't know who Izzy Swan is, he's been doing the woodworking stuff for years, and a little bit of CNC too. But he has come up with some really cool stuff. Almost 1 million subscribers. So my goal now is to help Izzy get to 1 million subscribers. He doesn't really care at this point. He's got 940,000, right? But just to help the man get that big gold plate from YouTube. It's so much fun to help other people achieve things. All right, so now I'm even more scared. All right. Do it. Any more questions before we rock and roll?
Not that I'm seeing.
All right, here goes, boys and girls. Hand on the stop switch. Going up to 20,000 RPM, probably too high, but if I can speed the feed up, we were running at 120 inches per minute. I got a pause in there, here we go. It looks like it's doing a compression bit there. It's still cut. All right, let's amp it up. Get a little bit of squeal there. So bring the speed back down just a bit. So my spindle speed is up a little too high. And I'm going to turn that down. Ah, much better. All right. So let's take these off of your ears.
What was that?
Yeah. Okay, so the spindle speed was way too high, and that's why it was squealing so much. And, oh, yep, see that? I grabbed the wrong bit. I grabbed an upcut. All right, so that's why I should be using the setup sheet. So I'm just really anxious on this thing. So no excuse. No excuse for that. But so that makes such a good point. I mean, this is why I made the setup sheet. All right, and I'm surprised Julianne didn't call me out on this one.
Oh, no.
Yeah. So we have the CNC project setup sheet, and that makes sure that you're doing the right bits and all that stuff. I got ahead of myself, and this is how we make mistakes. And I made a mistake. I grabbed the wrong bit. Could have had other things go wrong. And my speed, the bit is warm, so that spindle speed was up too high. Anyway, where's my brush? First run on the Altmill CNC router. First of all, I like that all that squeal, all that what?
Mark says, now you remember.
Yeah, of course, yeah.
Bubba says, go around the profile now with a bit out. Small chamfer, and it should
I actually could,
clean up the edges.
because it's I could put a roundover bit on it. You tell me. I mean, I'm live. You're hanging out. You guys tell me if you want me to add another. I can do a roundover bit on it. Roundovers make a nice little accent to signs. Actually, I encourage people to use roundover on sign because it just adds a nice little new accent to it.
Joe says roundover.
Damn you, Joe. All right.
Yep, LTX Design says roundover.
Oh yes, is okay. Where's my RB? We'll do a 1/4 inch. So I'm using the IDC Woodcraft 1/4 inch roundover bit. This is a pointed roundover bit, and that's different from a flat roundover bit, where this would be flat. There would be kind of a wider bottom here, and then the radius starts. Now here's the two differences with these kind of roundover bits. When you have a flat bottom roundover bit, you can create, it'll be ground to a true 1/4 inch radius, like 90 degrees. So from that quadrant to that quadrant of the quarter of the circle. When you have a pointed roundover bit, it comes in like that, so it's not a full 1/4 radius, 1/4 of the circle, the 1 quadrant, whatever you want to call it.
Okay, now I have a question. They're saying chamfer, CHAMFER. What is that?
What's a chamfer? All right. So a chamfer is basically it's a cut like that.
Okay.
So you got that and that. This is the project, and it's basically cutting that corner around.
Gotcha.
So.
A couple people said that, so I was curious.
Yeah. So no, I'm not going to do a chamfer on this. So the thing with the pointed roundover bit, I'm going to actually go a little bit deeper. So I got a video about how to set up roundover bits. So you can do the roundover effect, or you can turn it into a bead cut. And what that means is you can actually go lower and into the material, and then you'll have a little step before it goes into the roundover, and that's called a bead cut. So I'll probably do that. All right. So tell me what you all think so far of what you've seen with the Altmill. Again, somebody asked how much it is. So it's $3K, and then the spindle kit is another. Geez, 500, 600. And okay, I'm just going to check something here. Okay, so this may be a problem. Okay, I'm not going to do the roundover. So you see here, I've taped it down, but there's a little stress that was taken out of the project. And so now it's picked up a little bit. So if I try to do a roundover cut on this thing, then it's going to look like crap there. And just because the board's got a little bit of warp to it. So that's just one of the things when we're creating on a CNC router, when we carve, we're actually removing material that is supporting the project, the material flat. And so sometimes if you take a lot of pockets out of it, you'll start to get like it'll go from flat to like that. And that's because you relieved a lot of the stress out of the material. In this case, there's a natural tendency to want to bend. What are you laughing about now? What is?
Dennis said, if only we had used a vacuum mat.
If yeah, we'll get to that one next. But I just got to get this running. So I'm going to do the review on this, talk about the assembly, but I can talk a little bit about it right now. The assembly of the machine took about 5 to 6 hours. And I needed a large surface because the way it's framed, if you don't have I had to make a makeshift workbench, 4 foot by 4 foot workbench so I could put it together. Otherwise, you're doing it on the floor. And my days of kneeling down are over when I'm trying to put things together. So the framing, the framing went together square, dead nut square. And what that means is sometimes when you put machines together, the frame can actually be cocked like that or like that. And so when you get the frames put together, you've got to check that stuff. Same with the gantry. I am putting together, and I've been conversing with Mark on this to put together a machine setup, a new machine setup sheet that takes you through all the things you need to check in order, all the way to get that machine trammed in, squared up, make sure it's running accurately, lubed up, and a few other things. So, okay. Good thing is we cut all the way through. So here's that double-sided tape. It did hold the project, but it was probably just too much. Oh, it pulled that last piece up, so that's why it came up. Oh, don't pull it up like that. Come on, baby. Come on. There we go. All right. I'm gonna spray that up, and I'll just use a trim router, and I'll come around and clean that up. And get that nice little radius on there. I'm not gonna show you how to do that here. You know how to do that. So there's that. Okay, so more about the Altmill. If you decide to get it, I do recommend that you get the T-Tracks. I never used T-Track before, and I was looking at this thing going, I'm going to make a 4 foot by 4 foot spoil board. And when I got to replace that, I got to replace the whole darn spoil board. So that's where I went into T-Track. And so you see it here. It gives you quite a bit of flexibility. You'll see the video that comes out tomorrow talks about that. The assembly, the instructions were very clear. It took me step by step through the whole thing. A couple things that were not in the instructions and I did not anticipate. They did provide all the tools I needed, but because there was one thing, I had to actually get my own tool. And it was a 6mm wrench. So right in here, you got the bearing block that's holding the screw, and you can see there's holes back here. There's 3 holes that mount into the cross frame, and so I couldn't get to the other 2 holes because this whole thing came assembled. So I had to take these bolts off, and so I can get to those holes to get the screws in there. So that was one thing, and the other thing was wire management. When they tell you how to run the wires, but at the end you still have a clump of wires, and there's no instructions on how to navigate that. So you can look over here to see how I got that worked out. Julianne, uh-oh, crash. All right, we're gonna unplug that. I've dropped this light 100 times. So let me just take the camera real quick. Ooh, that thing's getting hot. Yeah. So yeah, I just bundled the wires up right there. There's the framing underneath. And I've got there you go.
Yeah.
I've got a base board here. So this is a full 4-foot wide piece of MDF, and it runs back just past the end of the machine because the motors are hanging off the back of the machine.
Let's take a look at that. 'Cause I
Okay.
like that feature.
Yep, okay, go ahead. And you can cancel that call and we'll,
Yep.
yep, so I just extended this in case I need to run it into the, if I run this into a wall, it's not gonna hit the motors here. Now these motors are closed loop, which is something you don't find much on the CNC routers up to this level. And what that means is it's communicating back to the controller, so if it loses position, it will stop. We're gonna have to cut this off in just a minute because the camera's getting very hot. This is the dust boot that they sent. I had to do a little jury rigging because they've set it up for 4-inch and I'm using a 2.5-inch. So I had to go to the hardware store and come up with some things, but it goes together pretty easily. You can take it on and off real quick just by that clamp, and you can also take it off by, which one? This housing can stay on there. It's been a while, so it's either pull or push. Okay, there we go. And it just goes like that, and then you can just snap it back in place. Ball screw driven machine. It's an air-cooled spindle. Very sturdy. It comes with the legs, and then it's got holes already pre-punched into it, so you can create your own shelves. And yeah, and the controls are over here. It's got the SLB, super longboard, which is adaptable. They built this to be a bit in competition with the Masso controller, but it's new, so there's not a lot of programs out there for it, but that's all open source too, so people can write programs, and it's also got a 4th port on it, so you can run the rotary, which I have right there. There's a box sitting right there, and I forgot to get this set up for the rotary because I'm going to make it so it sinks in a little bit. I want to get more diameter out of that rotary than what it's really planned for. All right, if this was helpful, give me a thumbs up. And remember, if you look into one of these machines, then use the link that I have. It's a good machine so far. Okay with the cuts. I did have the spindle turned up too high, so there is overspeed and there's overfeed, and I oversped it. So the feed rate was manageable though. All right, any questions?
Yep, we got, let's see. There was one that I missed earlier. Where was it? Is that plywood oak?
This is it plywood oak? No,
Okay.
this is solid store-bought oak. You can just take a look right here on the end.
Okay.
All right, so and then
Glued together.
yeah, we joined 3 pieces together.
And then we have, oh, thank you to David. We appreciate you subscribing.
Hey, David, cool.
And then we have how much difference between air and water cooled spindles?
Let's turn on the water cool. So I gotta let the spindle power on. As you can see, this is my desk at the moment. I will turn this spindle on. So let's just put in that command. Oh, I unplugged it already, so I can't turn the spindle on. So let's do that. There's not a lot of difference. Here, the big difference with water cool and air cool is the if you start working in hot environments or something like that, eventually your coolant flow or your airflow is not going to compensate. Your coolant flow can actually get too hot too, right? So, but coolant flow is more manageable, it just keeps stuff moving. The risk that I actually had the hose pop off my little flow indicator. I didn't have it pushed in all the way. And so that got a little water on my spoil board. So you want to make sure that is taken care of. So let's just turn the spindle on to, let's see, M3 S, oops, S20000.
He's curious about noise.
Okay. Well, you heard the noise in the video. If you weren't watching the cut, go back in this video after it's been posted and you'll hear the noise. So I had a little more noise out of it because I had my spindle turned up too high. So this is 20,000 RPMs with an air-cooled spindle. And I'm going to just hold the microphone. So I was about a foot away from it, pointing my um, microphone directly at the spindle. Now we're going to turn on the water-cooled spindle, which is, this is an 80 millimeter spindle. We are going to go to manual and turn it on. And we're going to bring that up to, okay, so it's significantly quieter. All right, and so there's the flow meter right there, showing that we've got coolant flow. I always recommend that if you get the water-cooled thing, you're going to have to get that flow meter. Very cheap. Get it off Amazon. I can link that down below. And then down below here, get that wasp out of the way.
We have a wasp.
Okay, right down here is the water bucket with the water pump in it. All right. So let's get that out of there.
Is the new one 80 or 65?
So that's a
millimeters?
60. Well, I think that might be 80. Let me go measure. Yeah, this is 80. Yep, 80. So they're both 80s.
Yep.
1.5 kilowatt. And just for your information, if you go to like I think it's a 2.2 kilowatt, for I was talking to a couple people that are technically savvy on the spindles, and they said that the 2.2 kilowatt spindles running off a 110 don't necessarily have more power because they're not getting the amperage from the 220 circuits that they operate better under. So that was just an interesting little tip. So these spindles are putting out pretty much the same power as a 65. Yeah, the 65 diameter one. Any more questions?
Not that I'm seeing.
Okay.
A lot of people just saying their dust collection's the noisiest thing.
And mine is too. Yeah, I am actually going to replace my dust collector. So this thing is quite noisy and it's big. This came when I bought the Phantom, but I am going to get one that's more stealth. Because I don't like noise. I wear hearing aids, so I got to be very protective of my ears. So, yeah, that's it. So, again, we'll link all the stuff we talked about down below if we can remember. And yeah, again, use the affiliate link if you want to go look at that. The questions I get quite a few times, I got earlier, how does it compare to the Onefinity? So the Onefinity assembles easier. It's less parts, I know that. The Masso controller is a bit more complicated, not as user-friendly as the G-Sender software is. It requires a lot of learning behind that because it's works more at an industrial level, but it actually looks industrial too, but it's supposed to be a really good controller. I have to say they're probably very comparable in as far as the robustness between the two. The difference is the Onefinity, I know that you buy it, you have to either build your table or buy the table that they sell for it, like a little roller table. The Altmill actually is built with, it comes with the legs, but you can actually put this thing together without the legs. So the legs are just an attachment onto the extrusions here. So if you want to come up with some other thing, like set it up right, or something like that, you can do it. Can handle 4-foot full sheets, 4 foot deep, so you can do tiling on this. And I think that's about it. Any more questions? All right. Well, I'm satisfied with the first cut, just playing around, and yeah, fairly clean. Except for it was turning too fast. So when I was had my RPMs up too high, and I got that squealing. Basically, what that is that it's starting to vibrate, and the bit is actually starting to vibrate in there, creating like micro chatter, and that's going to leave a rougher surface on there. So I could feel that right there. So that's my fault, but I wanted to see what it's capable of, push it to its limits. Once I backed it down, that squealing went away, and it sounded like it should sound. And so that was done with the IDC Woodcraft up cutter bit, which wasn't a down cutter because I didn't follow my setup sheet because it was just too aggressive. Very common mistake that us newbies make. Well, I'm not newbie. It's a bad habit for an old dog that's been doing this for quite a while. So with that, we are going to knock off for the day, and I got some other work to do. Thanks for hanging with me, and have a great day, and watch for that video tomorrow about the T-Trucks. What?
One last question.
Fire away.
Do you happen to know if Altmill distributes in the UK? I haven't looked yet.
I think they ship anywhere. Yeah,
Okay.
yeah, I think they ship anywhere. As a matter of fact, I'm sure they do. So,
All right.
yeah. Okay. With that, we're going to check out. Make sure you check the description once we get it updated.
Thanks,
All right, we'll
guys.
see you later.